Today, we will explore information system supervision with graph databases. And mostly, this field of IS supervision is very interesting for us operators because we have a huge IT system and we want to dig into this system and try to make things emerge. Some indicators, some indicators of network bandwidth, of storage input, output, and so on. So we want to build supervision systems, and we want to understand what our IT is doing, what are incidents, where they are located, how we can solve them, and how we can predict them. Okay? This is a teaser, how we can predict incidents. As far as architecture is concerned, we built a solution around integration. So we integrated together Talend to load data, Neo4j to model or IT data model, and a ClickView dashboard. We did that because we had no other choice. The competencies were on ClickView and Talend. We could have done otherwise, and I explain why. And we will also see which insights we got from using Neo4j on agile project management. So let's start with the demo, and then I will explain how we built our solution, if the demo works, and if it doesn't either. So this is there you can see a ClickView dashboard with showing incidents, flows, applications, numbers. This is just a nice dashboard. And then we have different tabs. We can focus on any given application and try to filter with ClickView adaptive data model. You can filter on incident severities, criticity. So I can select them, and the dashboard changes. And I can represent the application within its environment. What are the flows that are exchanged between applications? And I can isolate incidents that occurred on this given application. So this is for, you take a given point in your IT application graph, and then you see what's around as other applications are concerned, or also incidents. We also have developed a dashboard on incident statistics per month, and you can also use your ClickView filters to make the dashboard change if you select different criticities. And finally, we try to see to dig into the graph topology and see if we could find anti-patterns in our IT application urbanism. Anti-patterns can be applications that flow data together, and then the data comes to the initial application. Or it can be spaghetti plates with many connections, many-to-many connections between applications. And it would be good to put a bus, an enterprise bus, between those applications. So we can see it in the graph, and we can isolate anti-patterns in the graph. Anti-pattern matching can be our specialty. I won't extend much on the demo, but I try to explain how we did. So how we ingest data, how we modelize data in the graph, and how we try to interrogate the graph. As far as information system supervision is concerned, we can build very complex data models, but we decided to start very simply. In fact, we first have applications which exchange flows together. So the first nodes we design are applications, and the first relationship we design are a flow relationship, okay? Then we have incidents, which are our second entity. And, well, basically, application has incident. So semantically, I'm not reaching very far, but this is the beginning of our data model. Then we enrich this data model with properties on relationships and nodes. For example, we can precise if any given application is a production application or a development or integration application. We can also have insights on flows, because flows can be FTP, SQL, and so on. We can also have bandwidth inquiries on flows, and so on. So we enrich the data model, the simple data model, with properties. And then the question came, the very question, how can we predict incidents in our IT? And I clearly remember this is where I asked a Neo4j support from Stefan Armbruster, who encouraged me to build the graph of time. I said, he's nerd. But anyway, we did it. So we tried to build connections between the days where incidents occurred. And this is so a very simple graph of time stating that there is a day after another. Good. And we can interrogate this graph to see, for example, I have an application with an incident occurring on the 31st of January, say, of December. And then this application has flows with another one. I want to query the graph to find other applications which exchange flows with application 1, but have not got any incident signaled the very day of the incident, or the day after, or the day after. So I can query the graph to find that. So this is very interesting because most of the time supervision is made on an application per application basis. You don't analyze chain reactions. So this is what we propose to do. And after talking a little bit about architecture, I'll show you, I think we got the time, some simple cipher queries to interrogate the graph and try to find the next best action for the supervisor, for the operator. What should I do when I have an incident signal somewhere? I want to know if there are flows that could propagate the incident to other applications of my IT. So this is what we're going to do. So we took data from our IT referential, but also from real data coming from supervision incident applications. We used the Talend ETL to make our life easier. But we also tried to ingest data with the low TSV facility, which was great too. We put this data into Neo4j with our simple data model we showed. And then we built the click dashboard above this using special libraries and special JDBC driver, which is issued by TIQ platform. A bit of cipher. So to warm up, I query the graph and I return my distinct labels, so my node types. So I have applications, incidents, and also I have the graph of time with the root date and the year, the months, and the days. This is for you to improve your French. I put the labels in French. So next, I can count my IT applications as if I had a classical relational database. This is to warm up. So I have nearly 5,000 applications in my IT. Great. And I can isolate a given application in my IT, which is called path kt root, blah, blah. And I want to see which incidents occurred on these applications. And with 5 lines of cipher, I can easily do that. We can also isolate incident start day and end day, and query the graph more to understand what is the resolution time for incidents on this given application. So I can try to find applications whose incident solving took between 5 and 10 days, and for this I query the graph of time. Yeah. So for example, the first application here has an incident beginning on the 3rd of January and ending at the 8th. So yeah, I know this is real data, so for us, Orange, some incidents do not solve before 5 days. Difficult to realize. Yeah?
What is the time resolution? It's just days, or you build internally, we have things like that?
Internally, we have more precise things. At the second, the operator declares the incident at a given time. This is a timestamp. Yeah. We simplify the data model. So how to predict incidents? Well, I will match an application that exchange flows between another. So this is my first pattern. And then the application has an incident on a given day, J1. And this day is followed by other days where the other application has not incidents. Anyway, I will execute the query. If you didn't understand, this is not so. So I can isolate applications for my IT supervisor, which have not undergone any signal incident, but I want my supervisor to check if this is the case. If the incident occurs on my epicenter application, I want to know if there is a season in my application IT. Okay. We can also isolate those anti-pattern in our database, in our IT application. So, for example, I isolate a bunch of 3 applications that exchange many flows together. There are 4 flows between each pair of application. So maybe, and we also isolated more intricate things in the IT. And typically, we definitely want to build projects to replace those spaghetti plates with more urbanist things, buses and so on. So Cypher does it. And let me finish with agility. We got pretty much insights on graph advantages for agile project management. So first of all, yes, Requires cat in Apache V model. Yes, of course, the V model, I won't teach you anything about that, but this is not adapted to agile project management. And the adaptive data model we saw in our example is very useful for project agility. We want to change of minds during projects, so we want the data model to change. If I want to add other properties to my nodes, I can do it on the fly. The reason also is pushed by the market. The market wants proof of concept before being convinced that I will use your solution. So we have to build rapidly technical solutions to our customers. And finally, agility is also on top of the architecture tools. And we chose to develop click dashboards without writing a line of code. There was click code anyway, but not Java and so on. Also, as far as risk management is concerned, there are many projects that are there are many projects that undergo overruns, and I think if we spend our time refining the model and discussing about which model describes best the reality, we will spend less time rebuilding our solution every day. As far as skills is concerned, for the proof of concept, we used ClickView, the TIQ driver, and the Talend ETL to load data. But we can do we can find other solutions. If I have other skills in my team, I will use a JavaScript H5C3 developer, and I will use the fantastic REST APIs from Neo4j, and I will use Cypher queries and I don't know, load CSV to ingest data or other drivers. So the universe is open to build the projects with the skills you have. Okay. Also, yeah.
Can I have a question about the connection between Talend and Neo4j database? How easy is it?
Yeah, well, if you know Talend, this is a graphical user interface based on Eclipse RCP. So you take you drag and drop your components in your environment, and you establish connections, together between these components. And there are around 10 Neo4j components to connect to the database, to ingest data, to query the database, and so on. So this is just plug and play, but we had to work with Talend because at the beginning, Talend was compatible with 1.9 version of Neo4j, and we asked them to update their connectors because they were not able to add labels directly. When we create nodes, we want to assign a label directly, and we were obliged to do it in 2 times. First time I ingest data, and then I query, thanks to Talend, the graph to add the labels to the data I ingested. So we progressed together with Talend to be compliant with 2.0, 2.1 version. But, afterwards, I can show you some jobs. Anyway, the component that could not be replaced is Neo4j. You asked the question, so I already talked about close relationship with the vendors to help them build their connectors with our return of experience. Finally, I think I'm a little ahead of schedule, but it's okay. I think that there is really a reflection to have on data enrichment. I have a first data model that is adequate for my IT supervision system, but now I want to enrich it because I discover with ingesting data into Neo4j that my referential is a nightmare. For, I don't know, 70% of incidents were not linked to the application where it occurred. So when you ingest real data into Neo4j, you discover something about your referential. Your referential is not accurate. So you have to ingest real data to make it accurate. And then when you enrich your graph, you can overlay graphs together. You can overlay the real data coming from network probes, from incident applications, with your referential data, what you declared your system is. So this is really fantastic. And then the other insight I have is that most of the time we have market product owners saying, I want this use case to be implemented. Okay, so we will find a solution. This is a top-down approach. But if we dig into the data, into the graph theory, we can find use cases in a bottom-up way. And I think the graph theory can produce many, many more use cases. I quoted one for IT anti-patterns, spaghetti plates, and so on. But there are many more. So I'm convinced that we can discover new use cases by digging into the graph theory with our data loaded into Neo4j. And last but not least, I have rather the same conclusion as Emil. It's like in the brain, when you connect neurons, there is an ID. For data, it's the same. So thank you very much.